Anyway, good morning, everyone. I hope you had a good sleep. I hope you enjoyed the session yesterday. If you found the practical exercise at least somewhat confusing yesterday, just wait for the one today. It'll be much worse. So the main topic today will be state transition models, sometimes called Markov models, because unlike decision trees, they do not allow for state transitions. Essentially, like individuals in the studied population get distributed across health states, and once everyone is in the terminal health state, that's when the study ends, or that's the end of the analysis technically. While in reality, especially if you're studying chronic diseases, people can change from one health state to another. They can be healthy, then they can get sick, then they can get better, then they can get worse. And if we want to study certain diseases and do an economic evaluation of interventions on these diseases, we really need to allow for this longer time frame. And then we need to allow for people to change from one or switch from one state to another. So that's what the state transition models do. But before we get there, because state transitions happen over time, we first need to talk about time preference and discounting, which I briefly touched on yesterday, but today we will go in a little more depth. So when I reviewed my slides, I already noticed a typo, because this would be a pretty good deal. If I ask you to give me 100,000 rupees today, and I would give you $100,000 10 years from now, I think that would be a good deal. I actually meant rupees in both items, so please correct that in your slide deck. But would you take this offer? You would give me 100,000 rupees today, and I would give you exactly 100,000 rupees back 10 years from now. Why not? Like, it's the same amount. I'll give you exactly what you gave me. I will give you exactly the same amount back. Yeah. The value changes. Why does it change?
Keeps on reducing over a period, right?
Yeah.
What you could purchase today will not be able to purchase tomorrow.
Exactly. Like, one part of it is that in general the value of money decreases over time, because technically you can, if you give me 100,000 rupees, I can invest them, make more money, and then return you the original amount, but I will be richer by then. Another key factor here is that who knows what's going to happen 10 years from now. There's uncertainty. So maybe you give me 100,000 rupees and I'll leave this country. You will never find me. There's this uncertainty, that there's this risk that needs to be accounted for. So it seems that you all have the intuition behind this. This is pretty much what I just talked about. So individuals usually prefer present consumption to future consumption. And to induce people to give up present consumption, we have to offer them something in exchange. That is usually the interest that we offer them to do that. There's monetary inflation. That means that the value of money decreases over time. And as I mentioned, there's risk that money will not be returned. I will briefly explain the difference between simple and compound interest rate, but the simple interest rate, that's just like to get the first intuition, which you probably already have. In reality, like in practice, in cost effectiveness analysis, we don't really use this. But the idea is that we have, let's say we have some amount of money that we call it this like present value. That's the amount of money we have today. And simple interest is accrued in every period, but it only applies to the original amount that was originally, to the present value. So 1 year later, you will accrue the interest rate times the present value, the current amount. The second rate, you will accrue the same amount of money. So this is pretty easy. Compound interest is somewhat more complicated, but not by that much. The idea here is that in the first year, you accrue the interest rate times the present value, but that adds to the amount that is then you apply the interest rate. In the second period, you apply the interest rate to the amount with the interest rate for the first year. And in the second year, it just like keeps compounding, and the value of money over time grows faster. The nominal amount grows faster. So this is the formula we use to calculate what the money will be valued in the future. So FV stands for future value. So if we deposit some amount of money today, the present value, T years from now, we will have this amount of money. This is something you probably all know from your bank accounts. Discounting is just the opposite direction of the same mechanism. We try to get essentially the question is, how much money do we need to deposit today in order to have a certain amount of future value, certain amount of money in the future? So even though we have two different terms, an interest rate and a discount rate, they're pretty much the same thing. They just work in opposite directions. And the discount rate usually incorporates preference for current consumption. The higher the preference, the higher the discount rate. It incorporates expected inflation. Again, the higher the inflation, the faster the value of money depreciates over time, the higher the discount rate. And as mentioned before, it incorporates uncertainty. The more risk is inherent in this money exchange, the higher the discount rate we have to consider. So, let's say if I wanted to have a certain amount of money 3 years from now, that would be the future value. To get the present value, like what I need to deposit in my bank account today, it's just, like the same formula, just flipped. It's the inverse function. So we just divide the future value by the 1 plus the discount rate to the power of t, where t is the number of time periods in general. I was mentioning years, but that would apply only if the discount rate was annual discount rate. But you can have monthly discount rate, half a year, 10-year discount rate, and so on.
How do you calculate discount rate?
You don't calculate that. Discount rate is essentially a model parameter. That is something that you would find. Usually people use the general interest rate offered by the government, like some long-term bond interest rate. There is a lot of gray area in discounting and what the discount rate should be. We will talk about that in a bit. Currently, the general recommendation, at least in some countries, is to use 3%. But why not 2.5? Why not 5? So the value of the discount rate is something that you should also do a sensitivity analysis on.
Suppose if I am investing in some bond or something, if I am investing the money in some bond or something like that, the discount rate will be the opportunity cost.
Yeah, yeah. Yeah, there are ways to estimate it. In the cost-effectiveness analysis literature, most of the times people recommend to use 3 to 5% of a discount rate, but it depends. Like in some countries, I think Venezuela was recently suffering from hyperinflation, and in that case, 3% really would not be enough. As always, it depends.
The discount rate will be variable. And the discount rate will be variable. Like
Yes, it would be in the list of parameters, and you probably should run the analysis with 1%, 3%, 5%, just like to see if it changes the.
For a period of time, suppose it's in a 10 years period, would like the first few years maybe 3% later increase or decrease.
I mean, if you have a good justification for that, sure, but usually discount rate is assumed constant. But what the value of the constant is, that is a question. Yeah.
Where do we apply this discount rate?
You will see in a bit. I just tried to set you up for discussing the state transition models, because in the state transition models, people change from one health state to another over time, and when each health state has a different amount of cost associated with them. It is different if you incur, let's say, the cost of treatment, let's say it's 10,000 rupees. It depends if you incur it in the first year, second year, or 10 years from now. So to compare this cash flow at different points in time, we need to bring the value to the present value, or at least to the same time point, but mostly people use the present value. All right, so here's an example. Let's say we have a 2-year graduate program at a school, and these are US prices, so this is insane. And the tuition per semester in general is $20,000. And the school offers you to pay the tuition each semester before each semester begins. So there would be 4 payments before each semester. The plan 2 would allow you to pay the full $80,000, so 4 times $20,000 in advance, and you would be done with payments. And plan 3 would mean that you would pay annual tuition, but after each year is over. So let's assume an annual discount rate of 3%. And which plan would you choose? Just like gut feeling, who would choose plan number 1? All right. Who would choose plan number 2? All right. Some people would choose that. Who would choose plan number 3? It's pretty much like I don't see a majority picking one particular type. So, and that is actually like, I think this is a great example. Like this is, even though you get the basic intuition behind interest rate and discounting, these things are not obvious. Like it really helps when you just write it down and do the math. So let's take a look. So this is how it would look like. So we have 4 semesters. The semester 0 is essentially like before the first begins. And so under the plan 1, we would pay $20,000 before each semester begins. In plan 2, we would pay all $80,000 before the whole, before you start studying. And in plan 3, you would pay $40,000, the annual tuition after each academic year. And so then if we calculate the present value, so all right, so I gave you the annual discount rate. Annual discount rate is 3%. But in here, especially in plan number 1, we have payments that are per semester, twice a year. So we would need a 6-month discount rate. So that's what I briefly talked about yesterday. So we would go about it. So we know that there is some discount rate per 6 months. And assuming compounding interest, to get to the annual discount rate, we would have 1 plus r to the power of 2, the 2 6-month essentially interest rates need to equal to the annual discount rate. When we solve this equation, we get that the 6-month discount rate is 1.489. So almost 1.5, but not quite. All right, so we have this. And so now we can...
I didn't get it.
You didn't get this? So we know that the annual discount rate is 3%. So in order to get the future value a year from now of what I have today, I need to multiply it by 1 plus 0.03, right? Assuming compounding interest rate, if I switch it to 6-month type of a plan, then I would accrue some interest within the first 6 months of the present value. That interest would add to the present value, and then I would compound it in the second semester as well. Yes, sometimes I use compound or discount. So now I'm talking about going in the future. So that is essentially compounding, or the interest is compounding. Discounting is going back, but it essentially is the same concept.
They want to know what the D is the same as R.
So the D is the annual discount rate. R is the 6-month discount rate. That should be clear. Yeah, sorry. You're right. So we know that so to get the future value, so I have certain amount of money. That's the present value. I put it in my bank account. 1 year from now, I will have the same amount of money that I put in, plus the interest. So I will have present value plus present value times R, which translates to present value times 1 plus R, the discount rate. Does that make sense? All right. So let's say this $20,000 a year from now would be valued 20,000 plus 20,000 times 3%. Well, yes, 1 year from now times 3%. But only 6 months from now, it would be valued 20,000 plus 20,000 times this amount, this percentage. All right. So now we can finally calculate the future value. So for each time period, we will multiply this is the future value because we will need to pay exactly $20,000. The tuition does not change. So we will need, under the plan number 1, we would need $20,000 today before we start the studies. But then we would need $20,000 1 semester from now. So that's not exactly $20,000 today. Because if we put a certain amount of money in the bank today, with a good interest, we would get exactly $20,000 a semester from now. So this is when we do the math. So we would need $20,000 today, then roughly $19,700 to put in the bank, and a semester from now we would have $20,000. If we put this amount of money a year from now, we would have $20,000, and so on. For this one, it's easy. We just need to pay all $80,000 right away. For the annual payment plan, it looks like this. And so now when you add all these numbers, you can see, so this is the amount of money essentially you need today in order to be able to pay for the tuition under the different plans. So if if you're a rational person, I would pick plan number 3 because that is the cheapest way how to pay tuition.
I'm not clear with the previous slide, the D and R. How did we get that 1.4?
So we set up this equation, and we know that D is 0.03.
So 1 plus R square is 4, right? D is 3.
So R is unknown. Yeah, R is unknown. Is this working? Kind of feel that this stopped working. Did it? Hello, hello. Yeah, it died. No, it didn't. Hello, hello. Oh. Hello, hello. All right. Doesn't work, right?
Can you hear?
All right, let's try the on and off again.
It's off.
Yeah. All right. How's this? Hello, hello.
Mic problem. We'll change the battery.
I can try
Just hand mic for a few. We'll just change the battery.
Hello. All right, let's try this. Yeah.
They're confused about how you calculated R.
Yeah, I see. Are we good, or should I go over this again? Good. Well, if there are more questions, we can come back to this. All right. So the main point here is that cash flows at different time points cannot really be compared. All right. Sorry, what was the question?
This is still confusion between R and D.
Yeah, so R stands for the 6-month discount rate. D is annual discount rate. We know D, R is unknown. So we try to solve this equation for R. Good?
But usually R should be annual, right?
It doesn't matter, but sure. Yeah, sometimes these are the 2 letters that are most commonly used, R and D for the discount rate. But yeah, I kind of feel that R is usually the interest rate and D is usually the discount rate. Now it's picking. All right. So the main point why we even talk about time preference is that cash flows at different time points cannot be compared. What I mean by that is that, like this $20,000 a year from now is not the same as $20,000 today. And so when you do the cost effectiveness analysis and you see that certain people incur costs very early on, and some people have the same condition but 10 years from now with the same costs, which is maybe a little weak assumption, but let's assume that the cost of treatment is the same forever. Those people who get the disease later in life, the present value of their treatment is different than the present value of those who get the disease today. So that is important to keep in mind, that whenever there is some amount of money, or even health, which we will get to in a second, we always need to bring it to present value in order to compare different interventions.
Shouldn't you account the inflation to the when you're calculating in future if a patient will get 5 years from now a disease, it won't be the same amount as current cost of the disease.
That is exactly what the discount rate does. It accounts for inflation.
So if your discount rate is less than the inflation, then only it will be cost effective. It will be lesser than the person getting the current illness. If the inflation rate is more than the discount rate, wouldn't it be costlier for the person to get the disease?
So the one way how to get the number for the discount rate is to take the inflation. So then, by definition, discount rate would be inflation, exactly. If that makes sense.
Right? In your slide, you mentioned discount rate takes into account three things.
Yeah.
So the discount rate should actually be higher than the inflation rate.
Ideally, yes. But so
Because for future cash flow preference,
yeah, that is a fair point. I guess I would. What I'm trying to say is that to get the estimate for inflation, that's something, there is some statistics or economic bureau that will provide you with this estimate. The risk inherent in how to account for uncertainty, that's something kind of wonky. Like if you have a good way how to estimate that and add it on to the inflation rate, do that. However, that is often difficult. So ideally, yes, the discount rate should be slightly higher than the inflation, maybe substantially higher depending on the risk. But very often people take the inflation rate for discount rate.
Can I say that? Actually, the very good example of this is stem cell. You preserve your stem cell now, and 20 years down the line, you will need bone marrow transplant. That time it will be very costly. So it is better to preserve your stem cell. But the present value of storing that stem cell, if it is too high, that is why you have to calculate the discounting and all. Otherwise, it is not going to be costly. Presently, they are charging you 2 lakh rupees to maintain that stem cell. Then later on, 20 years down the line, you might have very cheap stem cell added. So that is how, in such examples, you have to calculate discount rate. It is preventive programs where discounting is very important.
Yeah. Please go ahead.
Otherwise, why we are taking this 3%? It's like based on that money value. The bank, if you invest money in the bank, we will get some interest on that. For saving interest, normally it will become 6% to something for the savings account. 4%. So it's the same that the interest rate for the savings account. Then that interest account will take it to the inflation rate also. Bank will not give interest rate to, they will adjust to the inflation rate. That's why considering that 3% will be the standard, taking into inflation rate and the money value of the future. That's why we are taking blindly that bank interest rate adjusted with inflation rate. That's why we are not giving any additional value for the inflation rate. It's already adjusted with the bank inflation rate.
Can you just verbalize that 78,257, 76,538? What does it actually mean? That I need to have only so much money?
Very good question. So the question is whether, how do we interpret this amount of money, the $78,257? That is the present value that we need to put in our bank account today in order to be able to afford this health plan type. Oh my God, it's this tuition plan. So if we put this amount of money in the bank today, we will take out immediately $20,000 today to pay for tuition. We will leave the remaining, $58,257 in the bank. If the interest rate is the same as the discount rate right now, in one semester, we will gain some interest on that amount of money, on that $58,000. After the semester is over, we will pay the next semester tuition, again $20,000. So at that time, we will have more than $58,257. It will be probably like $59,000. We take out $20,000, so we have $39,000 remaining in the bank account. We keep that $39,000 in the bank account until the end of the year, when we need to pay another $20,000. By that time, we will have like $39,500, let's say. We pay $20,000, and and leave the remaining 19,500 in the bank account. By the end of the second year, but by the end of the third semester, at the beginning of the fourth, we will have exactly $20,000 left in the bank account. So, in other words, I already said this. So if we put this amount of money in the bank account today, if the interest rate is, this much per 6 months, we will be able to exactly afford this tuition plan. Does that explain things?
You're making a saving on it. Instead of 80,000, you're getting 76,000. Actually, 4,000 you're saving in that.
Yep, exactly. So that's the thing, that if you pay the entire $80,000 right away, the school, the university, doesn't really need all of it right now. They need to cover their variable costs only for the first semester at first. And they can invest the rest and make money of it while you can't. So this is like a university would never afford, never offer these three health plans. I keep calling it health plans. I guess my brain is still asleep. These tuition plans.
And the T for plan 1 is 4 and T for plan 3 is 2. Is it like that? 1 plus R raised to T?
I'm sorry?
The time period. We got the R.
Yeah.
We have a raised to T. The T for plan 1 will be 4. Is it 4? Well, there are 4 terms.
T. What did you include for T in the 3-year plan?
T is this.
It's 6 months.
Yeah. So essentially, we have 6-month periods, and at the beginning, at the present moment, the T is 0. A semester from now, 6 months from now, that is one time period ahead. So we would put 1 for T.
So we need to individually calculate for each.
So to get this number, 19,707, I would do the future value, which is $20,000, divided by 1 plus R is this, and T is 1, because it's one period of time. And the fact that the one period of time is exactly 6 months is inherent in the discount rate, which is calculated for 6 months. Good?
So for plan 3, you start with that amount, 76, which is at the end of the academic year.
Exactly. So for plan 3, you need to put only $76,539 in your bank account today to be able to afford the tuition.
So for plan 3, the T will be like the 2, right?
Yes. To get this number, we would use 2. For this number, we would use $40,000 divided by 1 plus the discount rate to the power of 4.
So the question is the discount rate, whatever the interest you're talking about, is it normally the same as the inflation rate as decided by the government?
Well, that's what we just talked about. That it should be slightly higher because it also incorporates. Usually, that's what people use in their analyses because it's just a number that you can easily justify. That you took this number from the government, and here's a citation and period, and no one can question you on that. On the other hand, if you said we increased the discount rate by 1%, by 1 percentage point to account for uncertainty, then some reviewers can be like, is this a good assumption or not? But again, what should be the discount rate is very unclear, and there are discussions what the discount rate actually should be. Right, so I think I already somewhat touched on this, but just to reiterate everything. So when conducting a cost-effectiveness analysis over a long time horizon, Like if your cost effectiveness analysis is only within a year or a few months, you don't have to worry about discount rate. Prices will not change by that much, or the value of money will not change by that much. But if the disease in question or the condition in question is especially chronic over a long period of time, costs and consequences, by that I mean the health effects, will occur over multiple years. And then you need to account for the differential value of money and health over time by discounting these rewards. Like an example here is in a model of patients with type 2 diabetes, a drug that helps control H1, the A1C essentially, can prevent complications and their treatment costs that may occur in the future. So all those costs that would have otherwise occurred, that would be in the reference, would have to be brought to the present value in order to compare it to the new intervention. And what we also see very often in many models or many situations is that costs are usually incurred very fast in the near future, but the effects unfold later over time. You can think about it like if there is some intervention, some surgery, some new drug that you take today that will improve your life, improve your health and life over time. So you have to pay for the drug or the surgery right now, but all the health effects, all the improvements will be delivered well, they will probably be delivered maybe immediately, but also especially later over time. All right, so now let's give me a break, and I would like to hear your opinions on this. So it seems that we all agreed that a rupee today is worth than a rupee tomorrow. So what about the value of health outcomes? Does a life year in this year have the same value as a life year in the future? So to make it more tangible, if you knew that you were going to get sick, for sure, like there's 100% certainty that you will get sick at some point, but you have the choice when to get sick. Would you prefer to get sick today or 20 years from now? All right, so let's hear some opinions.
Because it's cheaper.
No, let's not even think about money at this point. It's just about health. Like, would you prefer to just get sick today, be sick for a year, and just get it over with?
Yes, today.
Or just postpone it later and.
Later.
See, so some people would prefer today, some people would prefer later. Can you? Let's say.
Pregnancy today.
Please.
For example, if a patient is, if I'm morbidly obese and I want to undergo pediatric surgery right now in India. Right now, pediatric surgery will be very costly because it's a novel new technology. But 20 years down the lane, the price of a pediatric surgery will come down.
20 years ago, obese.
Hypothetical situation wherein if it's a new technology which is brought into India right now, like say pediatric surgery, when by the time another 10 years, the cost of it will come down. Whereas if it is an intervention like a hernia surgery, which is a routine process, because of the inflation, the cost of that intervention will go up 20 years from now.
Yeah.
So it's not just about accounting for the money which I have in my hand, but also about the cost of the intervention over a period of next 10 years, how it will change, depending upon what kind of intervention it is.
Yeah.
That's what
This is definitely very good thinking, but I would like you to forget about money. money is not a problem at this moment. Just think only about it. Would you just prefer, let's say the condition is broken leg. Like you will have to, someone will break your leg, and you just have to decide whether they will do it today or 20 years from now.
I need to play football now. I need to play football now.
Sure.
Yes. It will depend on the state of health you are going to promise me by your therapy. If you say that my therapy will cause amputation of the leg today, then I have to live for 20 years with that poor state of health. So my quality of life or quality or will all be utility value will be low. So I'll have to suffer for 20 years more. Whereas if you offer me cure and perfect state of health after my treatment today, I'll rather have it done with.
Yeah, very good point. So let's assume that your leg will get better in both cases. Even 20 years from now, let's forget about osteoporosis. You just will have to live with broken leg for 1 year, and then you will be fine.
Future.
Now versus then.
You're in perfect health.
No, 20 years from now?
You want to have, depends on whether you want to enjoy your youth or whether you want to enjoy your old age.
Productivity of an individual decreases over the future.
It might be that 20 years hence, whatever illness we are talking about for today, might have better treatment options there. So it might be better to get ill 20 years. For example, 60 years ago when I had an infection, the treatment I received would have been very different to the treatment I get today. So that is also something that needs to be taken into account when you are looking at health outcomes. Some kind of treatment options.
What is happening, we don't know. Anything, we may fall sick or anything. What will happen?
One may not survive these 20 years also.
Good. There's more?
Talk about time trade-off later. We're going to talk about time trade-off later.
Time trade-off? Yeah. So the takeaway point here is.
What would you prefer?
I would probably prefer future, but that's just my gut feeling right now. The takeaway point here is that with decreasing value of money over time, we're pretty much all on board. That's natural, like we have the intuition, it makes sense. When it comes to health, it's not as clear. Some people prefer to get sick today, get it over with, and then just enjoy the rest of their life being healthy, theoretically speaking. Some would prefer to be sick later. So when we account for future value of health, should we discount it? Should we actually value it more? Should we, instead of one year of full quality life 20 years from now, should the present value be less than 1 year today, or should it be more?
There is a discounting, I think, that we use, and that is why the government invests more money in diseases which affects young people rather than that which affects old people. So that is basic.
Yeah. We will actually talk about exactly this in a bit. So we're getting to this. I already touched on some of these points, but there is huge controversy about discounting health effects. Should they be discounted at all? If yes, should the discount rate be the same as for discounting money? like, is the inflation that affects the value of money the same as the value as it affects the value of health? I don't know. The thing is that we do have financial markets, but we don't have markets for health. We cannot trade health. And so there is no good discount rate for health effects. And the field of cost effectiveness, it's been around for a few decades. But on the overall, from the big picture, it's a very new field. And many things still haven't been resolved, and this is one of the big ones. No one really knows what the discount rate should be for health effects. And therefore, the recommendation of the biggest experts in this field is just to use the same discount rate as we use for money, just because we don't have any better solution for that. So I'll just leave it there. You may disagree with this recommendation, but that's pretty much all you can do.
What does shadow price of capital mean?
That is essentially opportunity cost of capital. All right, so this ends the slide deck on time preference.